Hello, geometry students. In our last couple of lessons, we focused on parallelograms, and today we're going to move on to rectangles. The definition of a rectangle is a parallelogram, which is opposite sides are parallel, and it has to have 4 right angles. Pause the video and take a minute to determine which of the following characteristics are for a rectangle. Place check marks beside them. All right, let's see how you did. Opposite sides are parallel. Opposite sides are equal. Opposite angles are equal. In fact, all angles are 90 degrees. Adjacent angles are supplementary. Now our diagonals are going to be equal. This is a new one. Diagonals do not bisect angles. Diagonals do bisect each other. So let's take a look here for just a minute, guys. We said our diagonals are going to be equal. So those 2 lines are equal. Then these bisect. Diagonals bisect. That makes these 2 exactly the same amount. Now, this line and that line are the same amount. So these are also going to be the same amount. Now notice, people, remember this. We're going to use this trick. See that triangle? That is an isosceles triangle. So we're going to use isosceles triangles to help us find angles. See, these 2 angles are equal. And up here, same thing. Those 2 angles are going to be equal. We're going to use that isosceles triangle trick. All right, let's take a look at our examples. Number 1, we have a quadrilateral, and it is a rectangle, and then they give us the angles. Now, pause the video and try and do it, and I have the answer up there. Okay, so if you haven't gotten this one right, you need angle STR. STR. So I'm going to have to draw my diagonal in there, and that is 8x plus 3. My other angle, UTR, is 16x minus 9. So now you're saying, oh, that angle's 90. Add them to equal 90. Get your like terms together. 16x and 8x minus 9 and plus 3. Get x alone. Divide by 24. X is 4. Now you need to find the measure of angle STR, which was 8x plus 3. So plug 4 in there. That's how we're getting 35. Moving on to the next problem. We're asked to find the value of x and y. Pause the video and see if you can get this answer. If so, then fast forward. All right, so as I'm working this problem out, my concern is, I know opposite sides are equal, so I wrote my first equation. 2 variables, 2 equations. So my second equation, 2x plus y equals 36 because diagonals bisect. Those 2 are going to be equal. Now, 2 variables, 2 equations, substitution or elimination. When I look at my y's, they can be eliminated. I have 3x equals 45, x equals 15. Then take one of your equations and plug it in. 15 minus y is 6. Negative y, move your 15. I'm sorry, this is 9. Gets you negative 6. Y is 6. All right, moving on to our next problem. Take a minute and see if you can solve this on your own. If not, then watch the rest of this video. All right, now I've already written my expressions in. This is that isosceles triangle that I was talking about at the beginning of the lesson. This is an isosceles triangle. If you have two sides equal, then the two angles opposite are going to be equal. So 4x squared minus 6 equals 10x. Now we had one of these problems in our review where we have an x squared. So we know we have to factor it. So move your 10 over. And at this point, I'm sure some of you are saying, oh, we don't know how to factor this. I don't know what to do. Well, pull out what they have in common first. And they have a 2 in common, so factor out a 2. That gives me a 2x squared minus 5x minus 3 equals 0. All right, at this point now, I'm going to have to factor the 2x squared minus 5 minus 3. Well, this is comes from my first. So I need a 2x and an x. The minus 3 comes from your last. So I'm looking at my last. I need to put factors that multiply to get 3, actually negative 3. And my minus 5x is my inner plus my outer. All right, well, this one isn't too bad because when you've got negative 3, I only can think of 1 and 3. Could be a negative 1 and positive 3, 1 and negative 3. So I'm going to mess around here and try and figure it out. I don't know where it goes, but this is going to be my outer and my inner. So if I take negative 1 here and I put positive 3 there, my outer is a minus 2x and my inner is plus 3x. That does not get me my minus 5, so that is not correct. Got to erase. Try again. All right, so now, should I put 3 here and 1 there? I'm going to put positive 3 and minus 1. I'm doing my outer plus my inner. My outer is 6x. My inner is a negative x. Okay, that gives me 5x. I needed to have a negative, so I just need to change my signs. Here's what I need to do. Need a negative 6. So see that? That's negative 6. Change this to plus, then that's plus 1. That's how I've negative 6 plus x, negative 5. Okay, so I've got that set up. Now set each piece equal to 0. 2x plus 1 equals 0, because this has to be 0 and that has to be 0. 2x is negative 1. Divide by 2. That's how I get negative half. Second one. X minus 3 is 0. X is 3. Now can I keep both of those? Negative half. Negative half. I don't want to keep, because if I plug that in there, 10 times negative half is going to get me a negative number. So I don't want to keep that. All right, find all the measures if you're given angle 1 to be 37. 37. Angle 2 should be easy to find because this is a 90-degree angle. I'm going to write 53 there. Lines are parallel. This is your transversal, so this is an alternate interior angle, 37, 37. Remember, isosceles triangle, 37, 37. Now they start following up, don't they? Right angle, 90 minus 37, 53. All right. Same thing, parallel lines, parallel lines. Oh, down on the bottom, isosceles triangle, 37, Hey, this is an isosceles triangle over here on the left-hand side, 53. See how that works, guys? Also an isosceles triangle on the right-hand side, 53. You could then find this angle inside here, 37, 37, minus 180, 106. 106 for vertical angles. All right, 106, straight line here. So 106, 180 minus 106, 74. Oh, we don't have to find that one, but we're at 74 there as well. All right, let's move on. Okay, we got graphing, and we have to decide, justify this as a rectangle. I'm using the distance formula. I've already graphed mine. You're going to have to pause and graph them yourself. Now you're saying, hey, this is a rectangle. I can tell this Hefty. I'm not going to do anything. Well, you're going to have to prove it somehow. Maybe I won't have you graph them. You've got to use your distance formula. So some of you are saying, oh, should I do distance of sides? Well, if you know the sides are equal, it could be a parallelogram, or it could be a rectangle. So sides is not the way to go. You need to do the diagonals, guys, diagonals. All right, so I'm looking at my diagonals. I need to find the distance of BD. And I need to find the distance of AC, the other diagonal. So I'm going to use my distance formula. I'm going to take my B and my D. Negative 3 minus 3 squared plus 3 minus 1 squared. That should get me BD. Square root. Minus a negative 3 minus 3 is a negative 6. Negative 6 squared is 36. 3 minus 1 is 2. Squared is 4. Gives me BD. That gives me square root of 40. We've got to simplify our roots, which is root 4 and root 10. Square root of 4 is 2 root 10 is BD. AC. Use the A and the C points. All right, distance of AC, square root of, I'll take negative 3 minus 3 squared plus 1 minus 3 squared. Negative 3 minus 3 is negative 6. Squared is 36. I'm getting negative 2. Negative 2 squared is 4. Oh, getting sloppy. AC, AC, extend. All right, that means square root of 40, which again is 2 root 10, is AC. So yes, it is a rectangle, because diagonals are equal. All right, so we're getting close here on time. Go ahead and pause the video and plot your points. Something happened here. My points are, there we go. Okay, so I need to find it using the slope. So I need to find the sides are perpendicular is what I need to do. So I'm going to check and see if AB is perpendicular to BC. And then I'm just going to continue to go around is what I'm going to do. So you need to find the slope of AB. You need to find the slope of BC. And I've already done that. And so it ends up being that these two are not perpendicular. I'm going to get 3 over 1, and I'm going to get 1/3. Perpendicular has to be flipped with a sign change, remember? So this is not perpendicular, so I would stop here. If they were perpendicular, I'd have to continue on. Thank you, and you have good luck with that homework.